Hello, Miss Butcher here, and this video is on identity and inverse matrices. It's 3.8 in your book. Alright, so do you remember the multiplicative identity? It was 1, and that's because when you multiply anything by 1, whatever you multiply it by retains its identity. For matrices, we have what we call an identity matrix, and it looks like this. We use an I for our identity matrix. And if it's a 2 by 2, it's 1, 0, 0, 1. If it's a 3 by 3, it's 1, 0, 0, 0, 1, 0, 0, 0, 1. And you can have this for any square matrix, no matter the size. But just remember, it's always all zeros except for a diagonal of ones. So if you're doing multiplication, if you took a number and you multiplied it by its multiplicative inverse, which we know is the reciprocal, you would get the identity, which is 1, the multiplicative identity. And it works the same way. If you multiply a matrix by its inverse, you will get the identity matrix. So let me show you an example of that. I'm going to take these two 2 by 2 matrices, and I'm going to multiply them together. So remember, we're going to go across and down, across and down. We go 1 times 11 plus negative 5 times 2. And then we go 1 times 5 plus negative 5 times 1, and then we go negative 2 times 11 plus 11 times 2, and we'd say negative 2 times 5 plus 11 times 1. And when you do that math, 11 minus 10 is 1, 5 minus 5 is 0, negative 22 and 22 is 0, negative 10 and 11 is 1. So if I ever ask you to prove the two matrices are inverses of each other, you just multiply them together and show that your result is the identity matrix. And of course, now I have to show you how to actually find the inverse of a matrix. So first we'll do a 2 by 2. To find the inverse of a 2 by 2 matrix, so we'll go with the generic ABCD, you will take a 2 by 2 and you'll switch places for the A and D. The B and C stay where they were, only they switch signs. So switch A and D, switch signs on the B and C, and this is what people always forget, so don't be one of those people. You're going to divide it all by the determinant of the original A, or multiply by 1 over determinant of A, same thing. So you're going to divide each term inside that matrix by the determinant of A. So let's do 1. All right, we've got negative 9, 5, 6, negative 3. To the negative 1 power means we want the inverse. So I'm going to switch the A and D spots. I'm going to switch the signs on the B and C spots, and I'm going to multiply it by 1 over, and I don't know what the determinant is, so I'm going to figure it out. The determinant of negative 9, 5, 6, negative 3 is Chris, 27, minus cross, minus 30. So negative 3. Divide it all by negative 3. When we do that, negative 3 divided by negative 3 is 1. Negative 5 divided by negative 3 is 5/3. Negative 6 divided by negative 3 is 2. And negative 9 divided by negative 3 is 3. So this here is your final answer. So once again, you have to know this formula. I'm not going to give this formula to you. You have to memorize this. It is on the test. You need to know it. Okay, here's 2 practice problems for you to do on your own. Push pause, do them on your own, and then check your answer and see if you got it right. And here are the answers. The first one is 3/2, negative 2, negative 1/2, 1. And the second one, when you took your determinant, you got 0. And you can't divide by 0, so you don't have an inverse. When you have a matrix that has a determinant of 0, it has no inverse, and you would say that is a singular matrix. Single because it has no partner, obviously. All right, so now we need to talk about why we need the inverse. And we need the inverse in order to solve matrix equations. So let's go back to basic multiplication. If I had AX equals B and I said solve for X, you would divide both sides by A. which is the same thing as multiplying by 1 over a, right? So you would do x equals, and then you would do b times 1 over a, which is the inverse of a, or like that. However, I shouldn't have even written it like this. When we do matrices this way, you always have to put the a part first. You always have to put the inverse part first. Because order does matter when you do matrix multiplication. It doesn't matter in regular old multiplication. But when we do matrix multiplication to solve for x, if I have ax equals b, a and b being matrices, then I'm going to take the inverse of a and multiply it by b. So make sure that you know this, and you know that the a part, the inverse part, has to come first. All right, so let's do one. Here's your problem. A is 12753, B is 2, -132. AX equals B. So now solve for X. What can I multiply matrix A by and get B? So what we're going to do is take the inverse of A, and we switch the 3 and the 12. We switch the signs on the 7 and the 5. And we multiply it by 1 over 36 minus 35, which is 1. So we don't actually have to multiply by anything. So our inverse is 3, -7, and -512. We need to multiply that times b. Remember, the inverse always has to come first. So now I'm going to go across and down, and I get 3 times 2 is 6, plus -7 times 3 is -21. We'll go across and down. 3 times 1 is -3, plus -7 times 2 would be -14. Bottom left, across and down, -5 times 2 is -10. 12 times 3 is 36. And bottom right, -5 times -1 is 5, plus 12 times 2 is 24. So we get 6 minus 21, which is -15. -3 minus 14 is -17. -10 plus 36 is 26. And 5 plus 24 is 29. So that is what x equals, because we did the inverse of A times B. All right. Okay, guys, the next thing I'm going to teach you is how to do matrices in your calculator. Now, I know some of you may have already figured this out, and you thought you were smarty pants, but your next test will have a non-calculator and a calculator portion. So you have to know how to do everything I've taught you by hand, and you need to know how to enter it in the calculator. All right, so what we're going to do on the yellow calculators is we're going to hit Alpha Zoom, and that will take us to a setup for a matrix. So what you're going to do is choose the number of rows that you want and choose the number of columns that you want. So let's go with a 3 by 3, and let's make it a 3 row by 3 column. All right, so write that down in your notes, Alpha Zoom, and then you can set up your matrix. All you have to do then is hit enter, or go down to OK and highlight OK, and it'll put one on your screen that you can then fill in. There's another way that you can use matrices, and I kind of like this way because you can store them in your calculator, and that way if I give you an A and a B and a C and then I give you a bunch of different problems with them, you can just store them and use them. And so to do that, you're going to press second matrix. And this will give you a screen with a bunch of, like it'll say A, B, C, D, and across the top it says Names, Math, and Edit. So you're going to go over to Edit, and then you'll choose the one that you want to store something in, and when you hit enter, it'll give you, you type in the dimensions at the top, and you will just fill in all your elements. It kind of looks like this. And so now after you've stored your matrices in here for ABC, wherever, you can always, you can use them when you're in the main home screen. You just do second matrix, and then you select the one you want, and so it's stored in there. So you can do it using either method. So if I asked you to find the inverse in the calculator, all you would have to do is either enter the matrix in blah, 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 and then hit to the negative 1 power. Just hit the x to the negative 1 power. Or store it in there, and then just select that one, and of course do it to the negative 1 power, and then it will give you the inverse matrix. Alright, the last thing I'm going to teach you in this video is how to find the inverse of a 3 by 3 matrix by hand, because it's really tough. So normally I'll let you use the calculator for that, but and I'm going to go ahead and just tell you now that this will be a bonus on the test to find the inverse of a 3 by 3 by hand. So, you know, follow along, try to do this, try to memorize the procedure. If you can't do it, it's okay, but it will be a bonus on the test. So, you know, try your best to remember it. All right, this is the transpose cofactor method, and what that is says that the inverse of a matrix A is equal to 1 over the determinant of A, and since it's a 3 by 3, you'll have to use either the diagonals method or the expansion by minors method, either way. And then you're going to multiply it by A sub C, which is called the cofactor matrix, and I'll show you how to do that in a minute. And then to the t power means to transpose it. All right, and like I said, A sub C is the cofactor matrix. What you do is you're going to replace every element with its minor and sign. And we learned how to do minors yesterday, and we learned about the signs yesterday. And then A to the t power means to transpose it. You just exchange each row for each column. So let's do one example of that, and then you guys can go to bed. We are going to find the inverse of 2, 1, negative 2, 5, 3, 0, 4, 3, 8, all by hand. So the first thing that the formula said was 1 over the determinant of A. So the first thing we need to do is find the determinant. 2, 1, negative 2, 5, 3, 0, 4, 3, 8. I'm going to find the determinant. So I'm going to use diagonals method. I'm going to copy 2, 5, 4, 1, 3, 3. I'm going to go down, 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 and I'm going to get 48 plus 0 minus 30, and I'm going to go up, 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 and I'm going to get negative 24 plus 0 plus 40. So the bottom number, 48 minus 30 is 18. 18 minus negative 24 plus 40 is 16. 18 minus 16 is 2. So our determinant is 2. All right. Once we found the determinant, we need to find the cofactor matrix. So our cofactor matrix, that's the hard part, is a big old matrix. We're going to go 2's minor. If I crossed out 2's row and column, I'd have 3, 0, 3, 8. And you're finding the determinant of that, right? And then if I took 1's minor, I would have the determinant of, cross out 1's row and column, and you have 5, 0, 4, 8. And then negative 2's minor would be 5, 3, 4, 3. The 5's minor would be 1, negative 2, 3, 8. The 3's minor would be 2, negative 2, 4, 8. And the 0's minor would be 2, 1, 4, 3. Down here, the 4's minor would be 1, negative 2, 3, 0. The 3's minor would be 2, negative 2, 5, 0. 8's minor would be 2, 1, 5, 3. And we have to include the associated sign. So it's just plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, so when we do that, we have to do the criss minus cross 9 times. We get 24 minus 0 is 24. And then we have 40 minus 0 is 40, but there's a minus in front of it, so negative 40. We have 15 minus 12 is 3. We have 8 minus negative 6 is 14, but there's a minus in front of it, so negative 14. 16 minus negative 8 would be 24. 6 minus 4 is 2, and there's a negative in front of it. 0 minus 6 is negative 6. Minus negative 6. It's positive 6. 0 minus negative 10 is 10. With the minus in front of it makes that one negative 10. 6 minus 5 is 1. So that's our A sub C. We have the determinant. We have the cofactor matrix. We still have to transpose it, which is a little easier. You're going to take this row now becomes the column. 24 down, negative 43. This row becomes this column, negative 14, 24, negative 2. And this one would be 6 minus 10, 1, like that. So we have to take that transpose matrix, multiply it by 1 over the determinant, and I'm almost out of room, but we're going to half each of those numbers, and you will get a grand finale of... Hey, you know what? Let me pause for a second. If you've watched this whole video and you've watched all of this extra part, even though I told you it was going to be a bonus, I'm going to reward you. Here's a donut for your efforts. Sorry it's not real, but, you know, pretend. And write the word donut in your notes, and when you show me your notes, I'm going to look for the word donut, and if I see it, I'll give you 10 extra points on your notes. All right, so now for the actual answer to the problem. Voila. All right, now everybody have a wonderful night. Don't forget the secret word, and I will see you in class tomorrow.